Imagine clicking on a web app and waiting seconds for anything to appear. Frustrating, right? In today's world, every millisecond counts, and users expect instant responses, even on slow networks or mobile devices. As your React applications grow, so does the size of your JavaScript bundle, silently sabotaging your initial load speed and user experience. But what if you could slash that waiting time, deliver a lightning-fast first paint, and only load what's truly needed, without any extra libraries? That's exactly what you'll unlock in this tutorial. You'll learn how to optimize your React apps using native lazy loading and code splitting, powerful techniques built right into React and modern JavaScript. You'll see how to break your app into smaller on-demand pieces so users only download code for the features they actually use. You'll discover how to implement these strategies step by step, understand the underlying mechanics, and apply advanced techniques like preloading, error handling, and performance best practices. By mastering these skills, you'll create apps that feel fast, modern, and scalable, boosting your core web vitals, improving SEO, and making your users happier across all devices. And the best part? All of this, with zero third-party dependencies. If you want to future-proof your React skills and deliver top-tier performance, you're in the right place. Subscribe now and join a community dedicated to deep, practical web development tutorials that keep you ahead of the curve. Imagine a React application as a large, bustling city. Every building, shop, and park represents a feature or component in your app. When someone enters the city for the first time, it's inefficient to make them tour every single block and street before they can enjoy the main plaza. Instead, you want their first impression to be swift, showing them only the essentials, the city center, while the outlying districts can be explored as needed. This concept mirrors the challenge of initial page load in web apps. When users visit your React app, they should only download and render the code they need for their immediate view, rather than the entire application at once. This is where lazy loading and code splitting come into play. Lazy loading is the practice of deferring the loading of non-critical resources until they're needed, while code splitting is the strategic process of breaking your application's JavaScript bundle into smaller, bite-sized chunks. By intelligently splitting and lazily loading code, you provide users with a faster, smoother entry to your app, as they're not burdened by features they may never use. This results in decreased bandwidth usage, improved performance, especially on mobile devices or slow networks, and a better user experience overall. The city remains vibrant and expansive, but visitors only encounter new areas as they choose to explore them. Consider the difference between static and dynamic imports in JavaScript as similar to ordering a meal versus a buffet. In a buffet, static import, everything is prepared and presented to you at once, regardless of whether you eat it all. In contrast, ordering a la carte, dynamic import, means the kitchen only prepares what you specifically request, minimizing waste and wait time. In React, static imports pull all components into the main bundle, causing even rarely used features to be loaded immediately. Dynamic imports, using the import function, allow the browser to fetch only the modules needed for a particular interaction or route. React's React.lazy API wraps this concept, enabling components to be loaded on demand. When paired with Suspense, which acts as a placeholder or loading spinner, the experience is seamless. As soon as a user triggers a new feature, the corresponding code is fetched and rendered, while a fallback UI maintains engagement. This native approach eliminates the need for external dependencies, keeping your codebase lean and maintainable. It also leverages modern build tools like Webpack or Vite to automatically create and serve these code chunks, so developers can focus on logic and design rather than manual optimization. By shifting from a buffet to an a la carte model, React apps become more efficient, scalable, and user-friendly. This is the main application file implementing native React lazy loading and code splitting. It demonstrates route-based and component-level lazy loading using React.lazy and Suspense, with a custom loader fallback. Navigation between pages loads only the required chunk on demand, optimizing the initial page load and overall performance. This loader component provides a simple fallback UI while any lazy loaded component is being fetched. It ensures a consistent user experience during asynchronous loading. The error boundary component guards against errors during the loading of lazy components. If a dynamic import fails, it displays a user-friendly error message instead of breaking the entire UI. The analytics component is an example of a secondary page loaded via code splitting. It simulates a dashboard section that is only fetched when the user navigates to the analytics view. The profile component represents a user profile page, which is also lazily loaded to optimize initial bundle size and improve perceived performance. The settings component provides an example of preloading in action. Its chunk can be preloaded using import on a user hover event, reducing wait time if the user navigates there next. Heavy chart is a simulated large component, such as a charting library, that is only loaded when explicitly requested by the user. It demonstrates on-demand lazy loading for infrequently used features. This is the project's package.json configuration, outlining dependencies, scripts, and metadata. It ensures React 18+ compatibility for native code splitting features. The React application loads, displaying the main dashboard interface. On the home view, the user observes that the heavy chart component is not present in the initial UI, indicating that no unnecessary large code has been loaded up front. Next, the user locates and clicks the Load Chart button. After clicking, a loading indicator appears briefly. Once the loading completes, the heavy chart component renders, demonstrating that the chart's code was loaded only when requested, optimizing the initial bundle size. The user then scrolls to the section labeled Try Route Splitting and clicks the Go to Analytics button. The application navigates to the Analytics page. A loading spinner is shown momentarily while the Analytics chunk is fetched. When loading is complete, the Analytics dashboard content is displayed, confirming that route-based code splitting is in effect. On the Analytics page, the user finds a button to toggle the chart panel. Upon clicking this button, the panel is revealed with a loading indicator, showing that the chart panel component is being loaded on demand as a separate chunk. Once loaded, the chart panel content appears. The user clicks the toggle button again to hide the panel, and the UI updates accordingly. Using the navigation bar, the user clicks on Profile to switch views. The profile page loads, and a loading fallback briefly appears while the profile chunk is fetched. Once loaded, the user's profile content is shown, illustrating that navigation between routes only loads the necessary code for each view. On the profile page, the user scrolls to find the Admin Tools button, which opens a modal dialog when clicked. A loading indicator is displayed while the admin modals chunk is loaded. After loading, the admin modal appears on top of the page content. The user then closes the modal by clicking the Close button, and the modal is removed from view. Returning to the navigation bar, the user selects the Settings option. The Settings page appears with a short loading state, as the prefetching hint has already prompted the browser to fetch the chunk in advance, making the transition quick. The Settings form is rendered, allowing the user to interact with the theme selector. The user selects High Contrast from the theme dropdown. A Saving Us message appears briefly, indicating the theme is being updated. Once the process completes, the form reflects the new theme. The user then switches the theme back to light, again observing the loading and completion sequence. Finally, the user navigates to a route that does not exist, triggering a fallback UI. The dashboard displays a friendly error or not found page, confirming that the application gracefully handles unknown routes. The user scrolls back to the top of the application, pausing to review the overall UI and demonstrating that all dynamic imports and lazy loaded components have functioned as intended throughout the session. You've just seen how native lazy loading and code splitting can transform the performance of your React apps, making them faster, leaner, and more enjoyable for your users, all without extra dependencies. By applying these strategies, You'll ship products that load instantly, even as your codebase grows, and you'll maintain a modular structure that's easier to test, debug, and scale. Start experimenting with dynamic imports and Suspense in your projects right now. Watch as your initial load times drop and your user engagement rises. Want more actionable, step-by-step React insights you can directly implement in your own code? Subscribe now, because every week you'll get proven techniques and clear real-world examples that will accelerate your learning and make you a stronger React developer, faster than ever before.